Hello. Today we'll continue our talk about let form, but not only. And we will add some extra features, and finally we'll create our own macro. As for me, it's quite usable. It's still not present in Clojure standard library, but it's a matter of taste. It's well known Lisp feature that everyone tries to make his own macroses, to create his own macroses, and that's why it's very hard to to combine different codes, because it relies on different pre-built forms, macros, and so on and so forth. And yes, I know I heard a lot of suggestions like that. Please do not create your own macroses. Please avoid of macroses at all costs, and so on and so forth. But I don't know. I'm not afraid of macroses. I like them, and I use it not maybe so much as lambdas and its functions. Yeah, but for some cases of creating new syntax and maybe sometimes also semantic abstractions, as we described before, because let allows us to create local variables. Yeah, it's quite usable. So let's discuss some tasks which solves in some languages very easy. I like the languages with multiple return points from the function. Yes, I like the idea. It allows us to put a return instruction at every place, and then we can alter the control flow of the code very easy, very visible, and very understandable. And for example, the common case, as for me, is that we have a function, we have some input arguments, and inside the function we have to do both things. We have to do some checks and return function immediately if the check's not passed, yeah? And at the same time we have to do some calculations. Often they are hard weight calculations based on previous calculated values or on input arguments. For example, let's analyze this code. Function f from a and b, we calculate, made a hard calculation of variable x based on a, then we have a check if x is not fit the condition, we immediately return and do not anything else and any calculations below, yeah? Then if x pass check, then we have another hard calculation of variable y based on the previously calculated variable x, and if y is not past the test, we immediately return another error, and then finally we can return some expression which may rely on a, b, x, y, and all of the variables of function as input as internal ones. So the code is clean, very straightforward, very understandable, very usable, and quite nice. So what about Clojure and maybe some other Lisps in such type of logic? Yep, for local bindings we have a let form. But if we will use one big let form, we will have to move all these hard calculations on the top at one let block, and then have to do the checks below. But here you can see that if condition on x is not required, then we have to immediately return without any calculations below. And this calculation may have a side effects. That's very important. If a condition on x is not required, we have not to do any side effects, so that's not a way. And we also have in Lisp and Clojure emulation of multiple return block. It's cond macro. We can rely on condition, and if first condition is true, we can invert the logical condition, then immediately return some value. So multiple return blocks are presented, but it's very hard to include inside between of them, between all this condition, internal calculations. Of course, we can have a complex form with lot of nested ifs, lot of nested lets, and inside cond macro we can have nested lets and so on and so forth, but it's not so visible as for me. So that's why I decided to create a so-called cond let macro, which will combine benefits of both let and cond, and which can emulate the exact the same visual flow or a flat flow of this imperative code. So let's look on cond-let. It's of course it's not a big macro. It's very close to the cond. And it based on the thing that if we met a vector inside of in a place of condition, we will think that it's a bindings block and it's a block for let. Because no one will use a vector as for condition, because automatically Boolean value associated with any vector is true. So it doesn't make sense to have a vector in a place of condition in a cond macro. So let's see how it expands on some simple and complex cases. On more simple case, it works like regular if. If A then B else nil, yeah. On some more complex cases, we can read it this way. If A then return B, else bind variable pair to 1, then check if pair is less than 10, then return increase in value of B. We can rely to value of B here, else return 42. And this expands in desirable way. External if, then internal nested let block, which binds variable p, and all other calculations was made inside this let block. So everywhere below, from here up to blah blah blah, we can rely on this variable p. And that's the point, that's the goal. We emulate the previous described behavior of imperative language, imperative code. Then more complex way, it's multiple bindings. Let's show external if A then B, if C blah blah blah, first let, then if and second let, internal let, nested let. So it expands fine, and therefore it works fine. And even in some complex cases, for example, this is a code from imaginary backend project, and it expands this way. Here you see the one binding vector of two variables b and c, and in expansion you also see one let block. It binds b and c at the same time at the same variable. But even if we substitute it with two different vectors, so do this way, it will not a mistake, because it creates a nested let blocks, as you see here in REPL. First let block binds only b variable, let b increment a, and blah blah blah, and then immediately nested let block, let c, depends on b, but b we bind before, so everything will work either in this way or in previous way. Yep, maybe there is a point that the more complex macro is, the more hard to remember its conventions of usage, its semantics, the easier to make some mistakes, and so on and so forth. But from my point of view, it's every time it's a compromise, and I think this macro is quite readable and quite usable, and to read this and analyze this code and conditions and nested bindings in between the conditions and returning values, it's much easier to read than if we will implement it with nested how it's called, nested let blocks and nested if blocks. Anyway, it's unnecessary noise, as for me. So what do you think? Please write in comments. So thanks for watching. See you later.